Hello and welcome back to the vector section of the SQA Higher Maths course. Today we're going to look at something called the scalar product, also known as the dot product. And the scalar product is a form of vector multiplication. So there are other forms of vector multiplication that you will find out about in Advanced Higher Maths if you choose to take it next year, but in terms of the Higher Maths course content, the scalar product is the only form of vector multiplication that we cover. So the scalar product is denoted by A dot B, which is why it's called the dot product as well. And we calculate that by using the formula A dot B equals the magnitude of vector A multiplied by the magnitude of vector B multiplied by the cosine of the angle in between them, where theta is the angle between the two vectors A and B, which I've just kind of said. This formula is given in the exam, so we don't need to remember it, we just need to be able to use it. The definition above assumes the vectors are positioned so that they point away from the angle. Okay, so just every time, just make sure the vectors are pointing away from the angle. When think about them pointing into the angle as well, but it's best just to remember the vectors must point away from the angle. One can point in, one can point away, and we'll have to use this formula instead. Although I would prefer you guys just to remember this, and we can alter the question ever so slightly if need be, which we do look at in one of the examples. So example 1 here, two vectors A and B have magnitude 7 and 3 units respectively and are at an angle of 60 degrees to each other as shown below. What is the value of A dot B? Well, we know the magnitudes are 7 and 3. We know the angle is 60 degrees, so A dot B will be the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle in between the vectors. They are both pointing away, so it'll be 7 multiplied by 3 multiplied by cos of 60. So if we have covered the trigonometry section, we will know the cosine of 60 is 1/2. If we have not covered the trigonometry section yet, which may well be the case, we could just evaluate that on the calculator just now, and we will get plenty of practice at evaluating sine, cosine and tangent of 30, 45 and 60 degrees later on. So if it says in the textbook it is a non-calculator question, just use your calculators just now, guys, if you have not covered the trig section. Okay, so if we are doing this, for example, in the session 2021, we're trying to pick the topics that give the easiest progression from National 5 to higher at the moment. So we've gone for vectors before trigonometry. So just now, use the calculator and we will get 21/2. You could write that as 10 and 1/2 if you really wanted to. Example number 2. Vector u has magnitude k, vector v is twice as long as u, so the magnitude of vector v will be 2k as it's twice as long. The angle between u and v is 30 degrees. Find an expression for u dot v in terms of k. Now these vectors do not point away from the angle. Vector u points in, vector v points away. So remember guys, a vector just has magnitude and direction. A vector can occur anywhere, but it will always be that length and going in that direction. So I'm going to take vector u here, and I'm basically going to move it to the other side of the angle, to here. And if I do that, the vectors are then pointing away. And using my straight line knowledge from S1, or even primary 7 or primary 6, I know there's 180 degrees in a straight line, so if this is 30 degrees, then this will be 150 degrees. So u dot v will be the magnitude of u multiplied by the magnitude of v multiplied by the cosine of the angle in between, so that'll be k multiplied by 2k multiplied by the cosine of 150 degrees, which turns out to be -√3 k squared. Okay, we don't know the value of k, so we can't do anything to evaluate that further. Right, we also have the component form of the scalar product. So the scalar product can also be calculated as follows. So if we don't have the magnitude and the direction, or the angles between the vectors I should say, If we have vectors in component form, a1, a2, a3, b1, b2, b3, then a dot b is a1, b1 plus a2, b2 plus a3, b3. So that is also given in the exam. So here find p dot q, given p and q. So we are literally multiplying the x components together. So that'll be 1 multiplied by 2, plus 2 multiplied by 2, plus negative 3 multiplied by 3. So 2 plus 4 minus 9, which is minus 3. And let's bring that back in example 4 with a little bit of practice at finding vectors a, b and ac as well. So given the points a, b and c, calculate ab dot ac. Well, ab is b minus a, which turns out to be negative 1, 1 and negative 11. bc is c minus b, so again we're getting practice at finding vectors. So that's negative 2, negative 1, negative 4. Then ab dot bc, we are just multiplying the x components of ab and bc together. So negative 1 multiplied by negative 2, plus 1 multiplied by negative 1, plus negative 11 multiplied by negative 4, which is 2 minus 1 plus 44, which is 45. And that is the scalar or dot product covered. So have a go at exercise 6b and get in touch if you require any assistance.